This is the BLE Min application using BlockyTalkyBLE, both on AppInventor and Microbit. I'm going to give you a quick demo and then I will show you the code. So microbits have been found. So you click on Microbit List Picker. There is only one microbit around, so I choose that one. You can see on the microbit it now has a C for connected, which means now I can start sending messages. So I send a key value, and you can see that the microbit now spells out hello. And then by pressing buttons on the microbit, I can get an acceleration sent to me, a light value, and by pressing A and B at the same time, you can see that my name is Carrie. In this video, I'm going to go over the BLE Min AIA file for AppInventor and the BLE Min hex file for Microbit. I'm not going to show you how to build them because you can just download them both from the Laboratory for Playful Computation website, but I will explain the components in each file and why they are there. If you haven't done so, download the hex and AIA files and load them into AppInventor and make code for the Microbit. I'm going to go through the AppInventor design first and then show you the blocks. The list picker is really the only button that is required in this app. Everything else is recommended or as an example. The BlockyTalkyBLE extension is also required, and you can get that also from the same website. In order to connect your app to a microbit, you need to first scan for microbits and then choose one to connect to. Each microbit has a unique string name associated with it. Best I can tell, there's nothing on the microbit that tells you this name. You have to find it by connecting and making sure you have the right one. So you need to scan for the microbits that are running Bluetooth. BlockyTalkyBLE automatically scans for microbits whenever it is not connected to one and stores the name of the microbits in the list. The list picker button opens up that list and allows a user to pick a microbit. The reset connection button simply will disconnect from a microbit if it is connected. Otherwise, it really does nothing. Here, the connection status, I just use this so I can tell whether or not I'm connected to a microbit and whether or not a microbit has been found during the Bluetooth scanning. This button here is, the send button, is simply will send a key value, and this horizontal arrangement simply has a label for the key and the value. So whenever I receive a key and value over BlockyTalkyBLE, then I will put them on the screen. All right, let's start looking at the blocks. So up here I have a global variable called connected that I set to false. And as soon as an application starts, the BlockyTalkyBLE starts scanning for microbits. And whenever one is found, then simply I change the text of the connection status line to found microbits. And then I also get the information, or I copy over the microbit list into the list picker list. So when someone clicks on the list picker button and then chooses a microbit, then I call connect microbit and I give it the index that from the list picker microbit list, which is the same as the BlockyTalkyBLE microbit list. Connecting can take a while, so I have an event handler when the app recognizes that it's connected to a microbit, and I simply set the connection status to connected, and I set the variable connected to true. The microbit can also disconnect. That can happen if the microbit is reset, or if you download new code, or if someone walks too far away, or if you hit that reset button. So again, that takes some time. And so whenever the app realizes that it's disconnected, I simply change the label and the variable. And then here is the event handler for the button reset. It simply calls BlockyTalkyBLE disconnect, and again changes the, oh, it doesn't do anything. If it was not connected, then it simply says not connected to microbit. All right, so down here are two examples of how you actually use the BlockyTalkyBLE extension to communicate. So when you click on that send button, you can then send a key and a value, and they need to be strings. If you want to send an integer, you just have to convert it to a string. And here's the event handler for when you receive a message from the microbit. And again, it's got parameters, key, and value. And what I'm simply doing here is I'm setting those labels to show the strings, key, and value. Okay, now let's talk about the microbit side. So as you can see here, I have already downloaded the BlockyTalkyBLE package, which also installs the Bluetooth package. So I did that through the settings up here, add package. The other thing that I've done that's really important is I have set, and you can only do this once you actually have Bluetooth or BlockyTalkyBLE installed, I've set up for no pairing required. It can work with just works, or it can work with passkey pairing, but this just makes it easier. So going back to the blocks, there actually is nothing that is required here. There's a couple things I like to do just to make life a little bit easier. So I always like to show an icon on start, just so I know when my new code is loaded onto the microbit. And then I have a Bluetooth connected and disconnected, just so I can see if my microbit thinks it's connected to the app on the Android phone. And then simply what I've done here is I'm using the buttons to send a key and a value. So of course I use my name, Carrie. And then on button B, I'm showing you how to send a light level. So the thing to notice here is because light level is an integer, I needed to use a quick piece of Java so I set the variable item to the light level, and then I go into JavaScript like this, and I go in and then just write item to string like that. And then back in blocks, this is just the JavaScript code right here. So, and again, I'm showing how you can do that with acceleration also. And then here, every time I receive a message with the key show, I just show the string, the value on the LED screen. So that's it. Download the code to a microbit and to an Android phone and give it a try.